So what I would like to do is ask you, relative to global workspace, this global view of consciousness in the brain, what areas would you say, and we're going to be mammal-centric, at least for the moment, but because I'm going to hit you up later with a counterexample in the octopus.
Okay.
But in the mammal, what areas are relevant to the conscious experience in the mammalian brain?
The answer is at least twofold. For this conscious state, and you both know this, for the conscious waking state, there's brainstem mechanisms, and they pretty much, if you touch yourself back here and feel the back of your cranium, let's call that brainstem, and it does project forward into the thalamus, and the thalamus looks like the anatomical center of the cortex, even though it's not. And so then we get neocortex, thalamus, plus this huge expansion of the cortex that occurs with our biological ancestors. So cortex is the organ of mind, which was, I believe, Penfield's discovery in 1934, after studying waking human patients, epileptic patients who badly needed surgery. And nobody quite knew how do you do the right kind of surgery without endangering people too much. And the Penfield team, along with others, discovered how to do that. And suddenly you could talk to the cortex, right? Yeah. And that's been repeated. By now, I think there are 200 or more studies in the literature using pretty much that same setup. So you open
the back cortical stimulation.
Exactly right. So you open the cortex, just a little flap, you don't want to affect anything, and you protect it. And then you very gently stimulate the motor cortex, for example. Or more interestingly, actually this sensory body map, S1, called S1 for sensory 1. And suddenly this patient goes, I feel something. Holy moly. This was not exactly the first time, but it was close to the first time when, by the time he got done, he had 1,200 surgical patients that he had studied, and that kind of procedure became rock solid, and it has improved since that time. So we can talk to cortex, and so this is no longer entirely speculative.
And through Penfield's work, we were able to at least get the initial sort of framework of specialized brain anatomy. So that is aerial specializations for certain kinds of things. Right. Even though now we know that it wasn't completely, it's not wrong, but it's not the whole picture. So you can't simply talk about brain specialization.
Yeah, but that's the nature of science.
That's the nature of science.
He also predated, by far, fMRI, but he actually noticed it very early on that he could see the different colors in terms of blood flow and different activation. Really? He kind of nailed it in terms of fMRI, functional MRI, uses the MRI machine, but it's basically a blood flow detection.
Right.
Oxygenated blood has different magnetic properties than deoxygenated, and you can use this principle to kind of see where the action is. Right. It's a little bit indirect. It's sort of 3 to 5 seconds after the action, and it's. But Penfield in his writings, he kind of noted, that you could literally, once the lid is off, there's no pain receptors on the brain, so you're good to go.
Absolutely.
He could see flashes of color related to blood flow in areas of activation.
Really?
It sort of was small potatoes compared to the cool aspect of touching this part of the brain and listening to specific memory, magical type of discovery. Really? But he was like his colleague Hebb at the same place of time, so far ahead of their time, and we're kind of rediscovering many of the principles they put forward.
And